Okay. So let's go ahead. Quiet, please. So we're good. This is coming from the homework, but it also addresses items on the study guide. Right. The first one, which said evaluate the number 29 gives you an exponential model. Right. It's given to you, and the first step said fill in the table. Okay. So that means evaluate. I mean, just plug in for values of t and fill in the table. Right, that is one of the items on the study guide, is what we were doing in the first couple sections for exponentials and logs. So you could go through one at a time. Since t equals 0 was 1980, you plug in 0, 10, 20, and 30. Right? What I did is I just put it on y equals, and then I went to the table setup, and I set it to ask, and then I just plugged in 0, 10, 20, and 30, and there's all my answers right there. And you could do it one at a time, but you've got that thing right in your hand that does this stuff so easily. You understand where's the table set up? Right? It's above the window. And by setting it to ask, that just means when you go to the table of values, you get to fill in the x values you want. You don't have to scroll down to 30, which isn't so hard. But I think it's still easier. Just put in the values you want and get your y values from that. So that's the first part of the problem. The second part of the problem was find when, according to the model, when will the population reach 350,000? So what are they asking us to do with the 350,000? Put in the place of p for population. And then we'll be able to solve for t, right? That will be the when. Now, understand that the p is in thousands, so we just put in 350, not 350,000. So this will be 350 equals 20.6 plus 85.5 e to the 0.036 t. So that's an exponential. Solve it like we solve exponentials, meaning isolate and take logs. Right? So subtract 20.6. That should be 329.4 equals 85.5 e to the 0.036 t. Divide both sides by 85.5. 329.4 divided by 85.5. Again, I'm not going to simplify that. I'm just going to leave it. One last step, I'll plug in and get everything. Okay. Equals e to the 0.036 t. Right? Take the log of both sides. Right? Then we have ln of 329.4. That was wrong. Divided by 85.5 equals 0.036 t. Divide by 0.036. Right, all of that is in the logarithm. The 0.036 is not. So ln 329.4 divided by 85.5 and parentheses divided by 0.036. 37.465. Now if we were doing a problem solving technique here, which is, you're given a problem, you figure out the right math to solve the problem, you solve the math, but then you got to relate it back to what you asked to solve. When it said when, right, when will it reach that? 37.46 is not when. When is the when? Yeah, you got to add that to the 1980 was the 0 year, right? So add that. The actual answer is 2017, somewhere in 2017. Okay, that was 29. I think we had 31, which addresses solving a word problem involving exponential models. Although this thing here has been changed to 34. The problems that I think are most appropriate, I changed that. I'll change it online today. But let's see. The number Y of hits of a new website receives each month can be modeled by, and they give us an equation, right? Y equals 40, 80, e to the kt, where t represents the number of months that the website has been operating. In the website's third month, there are 10,000 hits. Find the value of k, and then use this to predict the number of hits in the website will receive after 24 months. Right? So in this kind of problem, it's not going to be as simple as we're going to either give you the y and solve for t, or give you the t and solve for y, because you got that k you've got to solve for first. How are we supposed to get at the value of k? Yeah, they gave us a data point so that we could plug in for the y and the t, right? We know that this y-t coordinate pair go together, so we can plug in 10,000, right, is going to go here when the third month, which means that represents a number of months, so it's 3. The only thing we won't know is the k, so we can solve for the k. Right, so this is 10,000 equals 4080 e to the 3k. Solve for the k. Divide by 4080. So this is 10,000 divided by 4080 equals e to the 3k, which means 3k equals ln of 10,000 over 4080. So what does k equal? .2988, call it 0.299. So now we can fill that into what we started with, right? Now we know the k. Now it's y equals 4080, right? E to the 0.299 times t. And then we can do the second back. How are we going to find the number of hits that they'll receive after 24 months? Substitute t equals 24, right? This 24 is going to go here. So y equals 4080 e to the 0.299 times 24. 0.299 times 24. 5,335,280. I guess since it's a number of hits, I should just round it to the nearest. 5,335,281, 282 as a number of hits. Does that look right? Okay. And then this is the other kind that we did. Remember, this was called the logistics growth model. In the end, it doesn't matter. It gives you the equation. You don't have to come up with that. That's why it says in the study guide, it says, solve the word problems involving the models, but the equation's given. It's not like you got to memorize those 5 or 6 models. it'll be given to you. Just work with the equation that you've got. Okay, so this is a conservation organization released 100 animals of an endangered species into a game preserve. The preserve has a carrying capacity of 1,000 animals. The growth of the pack is modeled by this logistics curve, okay, where T is measured in months. Estimate the population after 5 months. How are we supposed to do that? Plug it in. It's just an evaluate, right? Plug in 5 for T. So P of 5 equals 1,000 divided by 1 plus 9e to the negative 0.01656 times 5. One plus 9 second e to the x, which is negative 0.01656 times 5. $107.7. I'll round it off to 108, approximately. Okay. After how many months is the population 500? What are we supposed to do with that? After how many months is the population 500? Right. You're going to plug in the 500 for the P, right, and then solve for T. Right? We solved one pretty close to this the other day. So it was 500 equals 1,000. 1 plus 9e to the negative 0.01656 times T. Do you remember how we solved that the other day? Where did we get that exponential out of the denominator? I mean, if you're confused at that step, you can think of it like a cross multiply. Right? Put this over 1, and then this times this equals this times this. Right. So we would end up with this at this step then. 500 times 1 plus 9e to the negative 0.01656 t equals 1,000. And then divide by 500. Right. Which is going to make a 2, which is easy. Right, so now I've got 1 plus 9e to the negative 0.01656 times t equals 2. Subtract 1, 9e to the negative 0.01656, t equals 1. Divide by 9. E to the negative 0.01656 t equals 1/9. Take the log of both sides and divide by negative 0.01656. So I'm just going to skip that and go t equals ln of 1/9 divided by negative 0.01656. I mean, this time, understand, they're asking for amount of time. Is the amount of time going to be positive or negative? It's going to be positive. So notice what goes on in these equations every time, right? You're dividing by a negative here, but it's a logarithm of a number which is less than 1, which means it's going to have a negative value too. So at that point, a negative over negative, it will give us a positive t when we do this calculation. ln of 1 divided by 9 divided by negative 0.01656. 132.683, I'll call it 133 months. Okay. Okay, so that should be the end of the homework. Right, now we'll get to the quiz. All right, we're not doing well on these quizzes. Remember, you can overwrite your quiz grade by doing better on the test grade. But for most of this chapter, you sat here saying, this is easy, this is easy, this is easy. And you, in the end, couldn't answer some fairly direct questions, which are taken mostly out of the homework, or it's not the homework problem like right next to the homework problem. It's not intended to be tricky or anything like that. Remember, solving equations with a one-to-one property. We have two of those, right? For exponentials and logarithms. For exponentials, we want to make exponentials of the same base on either side of an equal sign. In this case, since it's 3 to the x plus 3 and 1 over 81, what do you think that common base is going to be? 3, right? It's got to be 3. Well, 81 is 3 to the 4th. So 1 over 81 is 3 to the negative 4th. Remember, negative exponents just flip you to the other side of the fraction. So this is actually 3 to the x plus 3 equals 3 to the negative 4. Right? If it says solve by one-to-one property, you have to have some place on there where it has the exponentials with the same base, and then you made an equation out of the exponents. Don't solve by taking logarithms of both sides or anything else, or skip the step that shows that it's an exponential equals an exponential with the same bases. Right? Do what it says, and we did several of these from the beginning of the chapter. Right? Now, since the bases are the same, that means the exponents are the same. X plus 3 equals negative 4. So x equals negative 7. Right. The next on the quiz was calculate the amount of money you would have invested at an annual interest rate of 2.5%. Invested $4,500 at annual interest rate of 2.5% for 30 years. Compounded monthly, compounded continuously. On the test, you will be given the compound interest formulas. Now, I think a lot of people had them. Some couldn't remember them. I never said I was going to give them to you. You should have tried to memorize them. But in this one, we're going to use this formula. A equals P 1 plus R over N to the NT. And this one, it'll be A equals P E to the RT. Okay, let's see. For the one on the left, A equals 4,500. 1 plus. The interest rate is 2.5%. How do I put that in the 0.025? Almost everybody did that right. There may have been one or two that were 0.25. Right, that would not be right. So 0.025, and if it's compounded monthly, what's the n? 12, right? So 12. And that's raised to the nt, right? So it's 12 times. And how many years is that? 30 years. I believe, especially on that one right there, there was a lot of putting the interest rate in the place of the 12. You put in 0.025. Remember, the formula is NT, not RT. That one's got RT in it. That one's got an NT in it. So that you could put in the calculator. It should have been 9,519. And since it's money, and 7 cents. Right. This one would have been 4,500. E to the 0.025 times 30. More people got that right than got the first one right. 9,526 and 50 cents. Again, you'll get the formulas on the test. Hopefully you won't make a mistake. If you got it right in front of you, you just have to plug in correctly. You know how to use your calculator. Right, the number 3. You are asked to find the domain and the asymptote. And on the test, the study guide says, state the domain, range, and asymptotes of these functions. And in the study guide, it says, see these graphics, right? So for the logarithm, the graphic is on page 214. It basically shows you, this is what a logarithm, the basic, let's call it a parent function, looks like before you've moved it around up, down, left, and right, and flipped it and all that stuff. This is what we know about a logarithm, right? It has an asymptote on the y-axis, which is x equals 0. And the domain is x greater than 0, right? Because it can never touch the y-axis, and it can't be negative. The range is all real numbers. So now we look at this logarithm, and what shifts do we see going on here, right? That's a up 4. The minus is telling you to flip it across the x-axis, right? It'll be going like this, which won't change the domain, right? In fact, the going up and down won't change the domain. Flipping it won't change the domain. But what about the plus 5? That's a left 5, right? That's going to change the domain. You take this whole graph and you move it 5 to the left, where's the asymptote? The asymptote, x equals negative 5, right? So the asymptote, x equals negative 5, right? Not negative 5. X equals negative 5. It is not a line. And again, you know, if you put negative 5, for all I know, you meant to say y equals negative 5, which would be absolutely wrong. And some did actually say y equals negative 5. Right? Vertical lines are x equals a number. Horizontal lines are the other. Right? And then domain, x is greater than negative 5, right? It used to be greater than 0, but now it's going to move 5 to the left. And it didn't ask you for the range. I think the test question will say also the range. What is the range of a logarithm? All real numbers. Nothing's going to change. Because of all the transformations, it's still all real numbers. Right? Didn't ask you to sketch it. Didn't ask you to describe these things. It just asked for the asymptote and the domain. Okay, expand and simplify. So this is where we use the properties of logarithms. Remember those 3 properties that we got? Product, quotient, power. And let's see, this one's got 2 of the 3 going on. Quotient and power, right? So how do I break up the numerator and denominator here? It's a subtraction, right? So log base 3 of 9 minus log base 3 of the square root of x. Okay, that is not done. There's way more to do there, right? What do I do with the square root? That's going to be a log base 3 of x to the 1/2, right? And the 1/2 will move in front as a coefficient. But you should recognize when you see log base 3 of 9, how could you write 9 as the power of 3? It's 3 squared, right? That's log base 3 of 3 squared. And now, because you match the base of the logarithm to the base of the exponential, how does it all simplify? It's just 2, not log 2, 2, right? When these 2 match, they cancel each other out, and you just get 2, right? 2 minus 1/2 log base 3 of x. Right? And the next was a condense. So now we use those same properties to take many logarithms and put them into one. Right? So which property would I have to use first here? A power property because of this 5 and the 3. Because we can't use the product or quotient properties if there's a coefficient. So you move them in as exponents first. Right? So now we've got ln of x minus 2 to the 5th minus ln of x plus 2 minus ln of x to the 3rd. Okay, now you could think of this in different ways at this point. Right? You could do this kind of thing. You could say ln of x minus 2 to the 5th minus, and then put parentheses, ln of x plus 2 plus ln of x to the third. You know, by putting the parentheses there, that minus changed to a plus. And then you could see this as a product property inside the parentheses and a quotient property here. But personally, I wouldn't do that. Once you've got all these logarithms, remember what I said. Remember, you're writing one logarithm now, not more than one logarithm. ln, right? There's going to be a fraction inside. Everything inside a logarithm that is positive goes in the numerator. X minus 2 squared, x minus 2 to the fifth. Everything that's in a logarithm, which is negative, goes in the denominator. X plus 2 times x to the third. When you get to the same place, but I think we get a lot of confusion when we're trying to do that. There was a fair amount of like having this be x minus 2 to the fifth divided by x plus 2 divided by x to the third. Like you tried to show a divide in the denominator, which is not correct. Right? It needs to be right there. Common mistakes are still like writing this with more than one logarithm. Remember, it's condensed more than one logarithm into one logarithm. You're never going to have like ln of x minus 2 over ln of x plus 2. Right? Remember, it goes into one logarithm. And then there's a few, not a lot, that like right in this spot right here, you're putting a plus. Right? You're still keeping a plus. But remember, it may have been a plus when it was two different logarithms, but when you condense them into one, it was a product. There's not a plus in between there. Okay, so that was the answer there. Are there questions on the quiz that I didn't already go over? Okay, then the rest of the study guide, let's look at. Right? Evaluate exponential and logarithmic functions. Right? We already looked at the evaluate a exponential function. That was part of the homework from last night, actually. But as far as logarithms, right? How would I fill in this table given this equation? You plug in for t, right? It just means plug in for t equals 5, 6, 7, 8, 9, 10, 11. You're going to plug in 7 times and just do the calculation. Right? That's all evaluate means. Remember, this came from the second section. Before we could solve equations at all we could really do was plug in for the independent variable and calculate, see what we get. So just plug these numbers in. Okay, use change of base formulas to rewrite a logarithm. How do you use a change of base formula to rewrite log base 5 of 16? Say again? Yeah, it's the log base 10 of 16 over the log base 10 of 5. So that's the part where it says write it as a common logarithm. That's the common logarithm. What would that look like as a natural logarithm? ln, right? ln means log base e. So, which is the same thing as saying ln of 16 over ln of 5. Okay, it just says rewrite. It's not saying calculate. It didn't say calculate. What about one of these over here? Rewrite as a common logarithm. The log of x over the log of 1/5. Done. That's all you have to do. Okay, convert exponentials to logs and logs to exponentials. Right? How do you convert log base 4 of 16 equals 2 into an exponential? What's the base of the exponential? It's 4, right? The base of the exponential is the same as the base of the log. Okay, what is the exponent? 2 because that's the logarithm equals the exponent. And then what does all that equal? What's inside the logarithm. So be able to convert. I'd say, you know, whenever I do those, and I can remember doing these like back when I was your age, I just had this little pattern of 4 to the second is 16. 32 to the 2/5 is 4. 9 to the negative 2 is 1 over 81. 64 to the 1/2 is 8. And just write it. Then should be able to go the other direction. How about this one here? 9 to the 3/2 is 27. How would that look as a log? As a log. Log base what? Log, that was wrong. Log base 9 of 27 equals 3/2. So you just be able to convert both directions. That should be the easy problems, right? Everybody should get those right. Solve using one-to-one property. And we did a exponential in the quiz, but here's a logarithmic. Right? How can I just take 31? If the log of 2x plus 1 equals the log of 15, then then 2x plus 1 equals 15, right? Then it must be what's inside the logarithms are the same, since they have the same base. Now, if they didn't have the same base, that would be different, but they have the same base. Right. So 2x equals 14, x equals 7. So remember, whether it's an exponential or a logarithm, if you have to solve with a one-to-one property, make sure there is a line where you have a log equals a log, and then you write that equation. Or an exponential equals an exponential, and then you write the equation of the exponent. Don't skip over that part. Okay, solve exponential and log equations. These are the problems in the study guide. I mean, all the problems in the book. Just as an example, let's try to solve an exponential equation. Remember that these were the steps right here. Right? Isolate the exponential, take the log of both sides, solve whatever's left. Right? So how do I isolate this one? Subtract 13. 8 times 4 to the 6 minus 2x equals 28. Divide by 8. 4 to the 6 minus 2x equals 28 over 8. Which you could simplify the fraction, but because I'm going to just put it all in the calculator at the end anyways, I'm just going to leave it. It's not worth writing another line. Okay, now we've isolated the exponential. Take log of both sides. Which log? Log base 4, right? So you have log base 4 of 4 to the 6 minus 2x equals 28 over 8. Oh, that was wrong. Sorry. I'm modeling what you're not supposed to do. Okay. Log base 4 of 28 over 8. Right? And now, how does the left side simplify? It's the exponent, right? Because the base of the logarithm equals the base of the exponential, they cancel each other out, and you just have 6 minus 2x. Okay, then you still have to solve, right? You've got to subtract 6, divide by negative 2. And that you could put in the calculator. Well, let me take that back. In class, if you're going to use this calculator, you have the log base function in the calculator, right? So you could use that to do a log base 4 of 28 over 8. If you are using an 83, like if you're at home using the one that was issued, then you got to do a change of base formula. So it's up to you, one way or the other. You need to be able to evaluate log base 4 of that. I'm going to simplify it. I'll call it log of 28 over 8 divided by the log of 4 minus 6 over negative 2. But here I'm just going to use, where do you find the log base function in this calculator? Math, and it's close to the bottom, right? Yeah. And so our basis for, it's 28 divided by 8. Oh, that was not good. Minus 6 divided by negative 2. 2.548. Right. Make sure if you're doing that in the calculator, right, that you either have to like have all of that in parentheses or put that in the calculator first, hit enter, and then do the divide by negative 2. Okay, solve logarithmic equations. And again, these are all the ones you could practice on, right? Here's the steps. We'll take one of them. Isolate. Well, in a problem like this, how am I going to isolate the logarithm? There's 3 logarithms. Combine them how? We just did it in the homework, or in the quiz. You're going to use one of those properties, right? Product property, quotient property, to somehow combine them. Remember, this was the one, because it clearly looks like there's going to be logs on both sides, that we're going to use a one-to-one property. We're actually going to go logarithm equals a logarithm and then make our equation out of the argument. So log base 2 of x times x plus 2 equals log base 2 of x plus 6. Right? So now since one log equals another, then x times x plus 2 equals x plus 6. So we didn't end up using the convert to an exponential on that one. Okay, now it's x squared plus 2x equals x plus 6. That's a quadratic, so the solving part means get everything on one side, 0 on the other. X squared plus x minus 6 equals 0. And then solve it any way you solve a quadratic. Is it factorable? Yeah, that's a pretty basic factor, right? X plus 3 times x minus 2 equals 0. So x equals negative 3 and 2. Okay, with the last step, check for extraneous. What does that mean again? Go back to the original equation and see whether you have any log of a negative number or log of 0. Let's see. If I put in the negative 3, a negative 3 here and here and here, then definitely both of those are negative. Can't do it. So that's extraneous. So this one is extraneous. How about the 2? If I put in a 2 here, no problem. 2, no problem. 2, no problem. So that one's good. That one checks. But the negative 3 is not in the domain, right? Logarithms have a... Yes. Yes. Find the extraneous solution. Okay. So the study guide, which I already sent out and posted on the website, is this. It's not just the page numbers and the problems. It's actually telling you this is what you're trying to get out of it. I mean, I tell you, when you go to this one here, they don't have great problems in the book for that. I mean, their problems are saying, like, describe the transformations or something like that, you know. That's not what I'm asking you to do. I want you to know the domain and range of exponentials and logs and how they get moved around with transformations. In the end, the question is, state the domain, range, and asymptote. Calculate compound interest, formulas given. Right? Evaluate exponential and logarithmic functions, meaning just plug in for the variable on the right-hand side, calculate the variable on the left. Right? Use change of base formulas. to rewrite logarithms. Convert exponential equations to logarithmic and logarithmic to exponential. Okay, all of the things of which we've done. I'm going to go through this. Expand and condense. Solve equations using one-to-one. Solve equations that are not one-to-one. And then solve word problems involving exponential models. There's actually none that are logarithmic. If you look in like the section 3.5, which is all the models, there's very little actual logarithmic models. Most of them are all exponential. So, and that's all there is on the test. And like I said, I think I already changed that. What I already sent out said 29 to 36. You could change that to 34. So, question? Okay, I'm here after school, both days before school. The review I just did will be on the website. I think after school tomorrow, I got a meeting at 3:15. This shouldn't take that long. I'll be right back if you happen to come. Okay, so if people are wanting to copy this, I'll leave it on that. You finish, and then I'll scroll to the next page.